Today we will discuss about add-ons. Add-ons brings additional functionalities to T-Box, typically new protocols. T-Box embeds a series of protocols which are Modbus protocol and all the IP protocol like FTP, SMTP, POP3, NTP, HTTP and so on. But there are a lot of other protocols that might be required for T-Box. First, to communicate to field devices, for instance ISO TCP to Siemens or Ethernet IP, or to SCADA like OPC UA, IEC 6870, MQTT, and so on. In this video, I will demonstrate 3 add-ons. The first one is DNP3 to communicate to a SCADA, then TCP dump, which allows to debug any IP communication, and finally the add-on pings that we can use to test a GSM connectivity. We declare the add-on from the RTU properties and we have a tab add-ons, and from this tab we can add additional features. First, we have to run a setup because the add-ons are available as standalone setup. For this, I can show you from our portal Jira. Once you are logged, you can search for protocols, for instance DNP3, and then you see an article, and from this article you can download the user guide and the setup. I will do this for the DNP3, the ping, and the TCP dump. Once we have run the setup of the add-ons, they are available into the tab add-ons in RTU properties. We can add and then we see which add-on we have installed. At the moment 3, DNP3, ping and TCP. So let's start with DNP3. When you select an add-on, it has its properties, and each add-on has its own set of properties which totally depends on the environment in which it is used. And for each add-on we have a help which consists in a PDF file in which we can see the description of all its configuration. Before we start with the add-on configuration, let's take a look to the different topologies. DNP3 then is a SCADA protocol. It means a SCADA will communicate to T-Box. It can be through serial communication or it can be through IP. In this example, we will use IP communication. And what will it exchange? It will exchange tags. So tags of T-Box will be required into the SCADA. So we will define which tags of the T-Box will go into the SCADA. We will have also to define IP settings to know how they communicate together. So if we communicate through LAN, we will work with fixed known IP address for both T-Box and PC. Typically, we will have more something like this. So we will have T-Box on the field communicating through a GSM network to the SCADA. In this case, IP address can be public. So if they are public, you can use DNS in T-Box in case the IP address are dynamic, and T-Box will use the IP address of the router to access the SCADA. If you work with a private IP and addresses and private APN, you will need to have fixed IP address, and you have to make sure that the SCADA can access the IP address of T-Box. This is quite complex in terms of knowing what kind of communication we can have with those IP addresses. So another solution is using one of our software called T-Connect, which is a facilitator of connection, and it will provide a subnet between T-Box and the SCADA, allowing SCADA to communicate transparently to the T-Box whichever IP address it has. Now let's start with the configuration. the configuration is divided into different groups of configurations. I will not describe all of them. I invite you to look into the document explaining the add-on to have all the details of each field. So we will still do a basic configuration to establish a communication. Well, first we have to specify an address. So this is the DNP3 address of the station. Nothing to do with the station address we have defined already at Modbus point of view. Here it is an address for DNP3 SCADA. Let's say for instance 5. This information can be accessible through a tag. Remember the runtime parameters, it allows changing in runtime the address of the T-box. This is optional. If you don't need to do that, you leave it empty. The listening port, we will work through TCP/IP. So DNP3 will use a TCP/IP port to communicate. This is by default the port used by DNP3. By the way, if you have activated the firewall, make sure that you open this port in the firewall. So let's make this to make sure that we will not forget. So if I go to IP security, firewall, so I will add this port, service custom, protocol TCP, the port 20,000, any source, and I will allow it through, let's say, Ethernet and through GSM2. Okay, so T-box will allow DNP3 communication. Let's go back to the configuration of the add-on. RTU properties, add-on, DNP3, properties, and properties. Okay, then we have different stacks that allows to maintain data. So DNP3 is an event-based protocol. It can be polled also, but it can also provide communication through event. So when a tag changes, it will be reported to the SCADA. But if the communication to the SCADA is interrupted, the event can be stored in a stack, and when the communication comes back, the events are pushed to the SCADA. The size of those tags can be configured. The tags generating events, also called unsolicited messages, can be sorted into different groups. There are 3, called class 1, class 2, class 3. So according to the importance of the event, according to the type of event, you can just associate your tags into one of the 3 classes here. Each group can automatically generate unsolicited messages or not. So if you enable a class, it means when the event of those class happens, it will be automatically pushed to the SCADA. If the class is not enabled, it means the events are stored in the stack, and when the class is enabled, which can be done in runtime, all the event will be pushed to the SCADA. We will need some tag in the configuration, and I have created the tags already for this video. So the reset tag is a tag that will allow to reboot the T-box on a command from the SCADA. So I will select this tag here. I created already. So in the group, you see a group of tag DNP3, DNP3 reset. And it means that when this tag changes to 1, I should reboot the T-box. And for that, I have created a small program. So in my list of programs, I have created a program DNP3. And you see on trigger pos of DNP3 tag, I activate reboot. And reboot is a system variable. Remember the system variable, which allows to reboot the T-box. So let's go back to our add-on configuration. Then I have a time synchronization tag, and this tag indicates to the SCADA that T-box required to be synchronized. So the T-box will raise these tags to ask the SCADA to synchronize T-box. In the group status, I have a series of status I have a series of status that allows me to debug command sent by the SCADA. And I have also 3 tags associated to the class. You remember the class here? Enable class 1, 2, 3. The configuration of the class is accessible through tags, allowing the SCADA or T-Box to change it in runtime. So let's add the tags. Once again, I have created the tags already, so I will just select them. Let's select the last one. Okay, now let's take a look to the interoperability configuration. It consists in defining the default variation for each group. The groups are types of data: digital input, double digital input, digital output, analog input, and so on. And for each, the variation consists in what kind of data is sent to the SCADA. For instance, for a digital input event, we can select to send the time, the absolute time, to send the value without the time, or to send the value with relative time. So for each type of data, you can select a default variation. Let's take a look now to the master. It corresponds to a SCADA, and we can add multiple masters. So I will add a first master. I give a name, okay, master 1. I give an address, so the address of the master, let's say 3, for instance. This address can be changed in runtime if I associated a tag to it. Then I select which type of communication I do. I do an IP communication. And I select the IP address of the SCADA. Now, if I go back to my topologies, if I am in a LAN, I probably know the IP address of my SCADA. So I just type the IP address of the SCADA. If I am in such a configuration, I might not know which IP address the SCADA has. So if I know it, I type it. If I don't know it, I can put 0.0.0.0. It means T-Box will answer to a request from any SCADA. IP address can also be accessed through a runtime parameters. So that's it for the general configuration. Let's take a look now to the tags. And the tags will be declared into different groups corresponding to different DNP3 types of IOs. So let's start with digital input. So you select the group and you click on the bottom add, and then you can add a tag. So each tag has a DNP3 address, which is a number between 0 and 65,000. Nothing to do with the Modbus address of the tag, just depending on what is required or what is already configured in the SCADA. So let's leave it at 0. Let's select a tag. Imagine that I want the door to generate an event to be reported to the SCADA. So I select the tag and I select which class it will be part of. Remember that class 1, 2, 3 can generate event. Class 0 does not generate any event, but it can be pulled by the SCADA. Set the door to class 1, for instance. Then we will add a new tag. Add, I will set address 1, and I will select, for instance, the tag start, which I will leave to class 0. Let's add another tag. Then I have declared the tags I need in my SCADA, so the digital inputs, the digital outputs. I have started the point numbering at 1000. This totally depends on what is required in the SCADA. I've defined the output with class 2, and I have also defined double output, trip and close, and the rule is that they must be defined with successive Modbus addresses, and they can be activated together. Then I have defined analog inputs at address numbering 2000, for instance, at class 3. And as far as analogs are concerned, the events are generated according either to a min or max or a deviation. You're obliged to put a deviation, but if you don't need event based on the deviation, you can set the maximum scale at the deviation, so it will never happen. And in this case, for instance, I want to generate an event when the temperature of the pump reach 80 degrees. Water level, I want a deviation of 5 units, and I also want an event when the value goes below 2. That's it for our configuration of the add-on. Let's save and send to the T-Box. My program has been sent. On my left side I have my list of tags that I have declared into my add-on. On the right side I have a simulator that will help me to check the communication with T-Box. It supports DNP3. On the bottom I have, in the watch window, I have put the stack of event in case the class does not report event, or in case the connection to the SCADA is interrupted. The event should be stored into the stack and reported to the SCADA when communication comes back. First, we have to establish the connection with the T-Box at TCP level. So here I will establish connection to the IP address of my T-Box using the port number 20,000. Click OK, and I am connected to the T-Box. Remember, I have the door. I have defined the tag door at class 1, but class 1 is not generating unsolicited event. Here, the class 1 does not generate unsolicited event. The events are stored but not sent. So let's change the tag door, and you can see here it changes. Open the door, close the door. Open the door, close the door. Now you can see that in the SCADA I can pull the tag by class. So if I do pull class 1, I will retrieve all my events, and I can see that my DI stack is now empty. Now I have defined other events based on analog tags. If my pump temperature goes above 80. And by the way, I have changed the format of the tag to words because this simulator is quite old and it does not support properly the float. So if my pump reach 80 degrees, it should generate an event. So let's increase the temperature. 80 degrees, and I have received a message here. 0.2000, 81 over range. When the value will go below the 80, so below the threshold, a new event will be generated to report that now it has been below the threshold. And each time you see, we can have the time. By the way, the time is UTC time, but you have an option to set local time. Let's take a look now to the outputs. So remember, we have this trip and close, and note that I have defined those two with successive Modbus addresses. And those tags are at point address The first one is at address point 1004. So it means that I will address the first one and it will activate both tags. So for this I have in this tool a direct operate window in which I can act on point number. So I select 1004 for instance. Then I can do a trip or a close. Okay, and if I click send message, it has been tripped. and close, send message, and look here, it will change, it is now closed. By the way, an output, you can also send a pulse. For instance, if you want to activate the valve with a pulse, you can select the pulse on. You select the address of the valve 1, it is 1001. If I do send, the pulse will last 1 second. If I click send message, we will see this tag raising for 1 second. 1, 0. Sorry, my mistake. I've set it on. Sorry. So if I do off now, it will turn off. If I take pulse, I have to take this one. Now send message. I have a pulse now of 1 second. So that's it for this demonstration here. Now let's imagine that if I look into my trace here, for instance, I see I have unknown variation. Okay, and this happens, for instance, if I activate the pump. Remember, the pump generates an event. The pump is here. The pump generates an event. If I activate start and stop the pump, well, I see it works, but I don't have details of what happens here. Well, this is just because of my simulator here. But imagine that you are facing such a situation with your SCADA, so you want to know exactly what T-Box is sending. And for this, we will use a new add-on, which is called TCP dump, and it will allow us to trace any TCP/IP communication. And we will trace the DNP3 communication between the T-Box and the SCADA. So let's start this. So I will increase this, and we will go to RTU properties, add-on, and we will add a new add-on, which is TCP dump. Each add-on has its properties, so I click properties, and the properties of the TCP dump, it's to have a trigger to activate the recording. So I have to define a new tag, so I will click here, new tag, digital. I will call it TCP dump trigger, and I will initialize it to 0. So I will not record by default. I will just record when I want. So I will not check this start capture immediately. And then you select which interface you want to record. If you want to record what goes to Ethernet 0, you put Ethernet 0. If it is the second Ethernet, Ethernet 1. If it is the GSM, you put PPP 0. And if you want any interface, you put any. So I will leave Ethernet 0 because this is what I am connected to. I click Save, OK, and I send this to T-Box. Sending is now complete. TCP dump will record a log into a temporary directory inside T-Box. So before we will start recording, let's take a look how we can access this file. And to access it, we need a new software called WinSCP, which you can have freely on internet. So I will show you the basic configuration for this software. So we have to select the SCP protocol. The host name is the IP address we want to access. So it's my T-Box. I just have in advance to change one timeout of connection to 30 seconds. And I can save. Then I can log in. It will log in at Linux level. Then I have to enter the SSH login, which was in our case John, myself. Not yet. Okay. Now I can go to the temp directory, and you can see there is already a file because I had tested the recording before. So this is the file recorded by the TCP dump, and you see that it has the extension associated to Wireshark. Wireshark is a software allowing us to analyze a TCP trace. Let's activate TCP dump. So I will switch the trigger to 1, and I will activate also DNP3. I am connected. I will activate the pump to see the event that I don't understand. Make it 2-3 times. I will also generate an event, another event like the pump temperature and also the water level. Okay, let's stop the trigger to stop recording by TCP dump. And I will now take a look into the file. I will refresh in WinSCP. So this is now my file completed. And I will download this file into my PC in a temporary directory. And we will analyze the file using Wireshark. This is Wireshark displaying the content of our log file, and you can see there is a lot of lines, lots of transaction, and a lot of Modbus transaction, because on the Ethernet port I also have the TwinSoft communication to the T-box. So in Wireshark you can define filters, and I have defined a filter to display just the DNP3 and the socket opening. So the socket is the establishment of the connection with the socket used for DNP3. So you see here the port 20,000 has been used to establish the connection, and the T-box has answered. Then we see our unsolicited communication, and we can see that the first one corresponds to point number 1000, which is our pump, with a timestamp and the value. So everything works fine. The fact that it was not displayed properly in the simulator is because the simulator does not handle properly this type of object. We had also defined event related to the pump temperature, which is point number 2000, and that was an overrange above 80. We did the same with the water level, with the minimum level below 2, and we have it here also with the value, and for each event we have the time in UTC format. So everything works fine, and we could check it thanks to TCP dump add-on recording the log file. This is it for TCP dump. Now let's take a look to our last add-on, which is the ping add-on. Before configuring ping add-on, let's see how and why we use this add-on. It concerns GSM connectivity. When you have an IP connection with your operator, the operator provides you with an IP address. It can be public or private. It's not the issue here. But you can never be 100% sure that this IP address is still communicating and connecting to the internet. Even if you see an IP address, even if T-box sees an IP address, it doesn't mean that behind everything is still running properly. So we might have to resume connection of the GSM. The best way to check the activity of an IP address is to use this connectivity. So we will activate a ping regularly to any public IP just to check that we are able to connect. And if after a certain number of tries it fails, we will just reset the GSM to resume the connectivity to the operator. So let's install the ping add-on. So the ping add-on, we go to RTU properties, add-on, add, and I select ping. And as any add-on, it has its own properties that I can check with an online document. In the properties, we have a first property, which is the Eric's timeout. So it is the maximum time we will wait for an answer. Then we have hosts, and we can add several hosts. So it means ping request. So you select the communication port you want to use to go out. I will use the GSM. I select as IP address, for instance, IP address DNS of Google. This can be defined as a runtime parameter. Then I have to define a trigger, which will be a tag that will activate the ping. I call it ping trigger, initialize at 0. And I define a ping time, which will return me either the time to have the answer of the ping or an error in case there has been no connection to the server. So I make a new tag, analog tag. It's 32-bit signed, and it's ping time. No initial value. Okay, okay, okay. So I can save, and I can send this to T-Box. The program has started. I have moved the tags to the GSM folder because the ping relates to the GSM, so it allows me just to check that I have an IP address and that I can do the test. So if I activate the trigger, I see the answer comes after 720 milliseconds, so the ping works. So each time I activate the trigger by pressing plus, I have an answer in number of milliseconds. Now the idea is that this works automatically. If we go to the help of the ping add-on, you will find an example of code at the end. So the idea is to have an event. The event is generated each 5 minutes, and each 5 minutes this event will activate the trigger. Now the trigger is resetted by the system, by the add-on. So you don't have to reset the trigger. When the trigger has finished his task, he will reset the trigger. When the answer from the trigger, so the tag time, is below 0, it means there has been an error. So we will increment the number of errors, and we will reinitialize the tags. If the time is above 0, meaning a number of milliseconds to receive the trigger, we will reset the errors and the other status tag. When we have had 3 successive errors, we consider that we have an issue with the IP connectivity. Then we reset the GSM. Note that to reset the GSM, you use a reset relay, okay, not a permanent relay, because it's just an action, a trigger action, and we reset the ping errors for the next time. So I have put this program here also. That you can see, and I can call it and use it in my global program. That's it for this video about the add-ons. No exercise or question this time. It was just my pleasure to make this introduction for you about the add-ons, and I hope it was helpful. Bye-bye.